Okay, so kind of, I've done a few test runs before this, but this is just just to kind of show everything's set up. So 19 volts coming out of here. I have this device limited to 3 volts, so that way it kind of makes it only limit 3 volts out of my charger, and 20 volts also the limit of this, the top limit. So currently it's doing 19 volts. Um, for the maximum of 3 volts or 3 amps, but I haven't reached that yet. But what's cool is I'm dropping it down to 14 volts, as you can see, and it's pulling 1 amp, which is cool. I'm happy about that. So it's able to already do a little bit more with with what's incoming. So I'm happy about that. At least that that way I'm getting more yeah, like I guess a good thing about it is so this will be a little bit cooler because I won't be pulling full amount of amps that this can do to get the top, because we're dropping the voltage. So I'll keep dropping this, and I've already checked the maximum is 5 amps, and if I do it all the way to 5 amps, a light will come on here, which is kind of cool, to let you know that you've reached the limit, which is great. So I theoretically cannot kill it. So even if I kill it if I contact stuff with metal and stuff like that. But anyways, yeah. So lights on right now, telling me that it's working, it's going, and then so we got a dial here. That's, that's the small amperage increase, and this is the larger chunk of amperage increase. So that'll go 2, 4. So it's already at 4, so 4 amps. But I had to drop it though just because the load is so big. So in order to keep up with the amperage, in order for it to draw more amps, it drops the load. And this thing can get pretty hot too. So which also might make it shut down too. It might end up turning off. But as you can see, I mean, look at that. Only one amp, 1.2 amps, and 4 amps. That's the big difference right there. Let's see, dial back. This goes 14. Okay, good. 13.9. So at first it'll probably be very slow, and then once it reaches the close to the top voltage, it'll kind of speed up and max out at like 4 amps. But yeah, so let's see, 14 point. 14.2, 14.2. And I don't exactly know if maybe it's obviously not pulling the full amount out of here, but that's fine. And I don't know, it might act differently on the battery. Maybe the less resistance, maybe the more current is going to flow. I'm thinking, I don't know how much resistance this DLE has, but basically turn the dial and then current flows into like a little piece of hardware down there, and that's what then it heats up, and that's why this fan turns on. So just testing out to see what it does, and I think soon I'll hook everything up, and I'll start the charging tomorrow and see how it works. Um, I'm not gonna charge with the USB-C quite yet. I'm only gonna do that connection onto the battery and just kind of give a rundown and see how it goes and see how fast it's charging, this and that, see if it's pulling a lot more amps, and it's set to open fully. So if it needs to, so if it wants to, if it can do 5 amps or whatever, it'll do 5 amps. But yeah, it's set to full 5 amps if it can. But as you can see, when it does that, in order to full 5 amps, it wants to drop it down. So and that's just my view due to resistances and stuff like that. Like even this will do it. Like if you want to full 10 amps, like it depends on what it is. Like if you're playing something that has, if there's a lot of resistance, then and you want to do 10 amps, it'll drop the voltage down. But if there's very little resistance, it'll keep it at maximum amperage and voltage. So I'm thinking that's what this is gonna do, and we're gonna have a bit faster charging, according to my calculations. So So yeah, yeah, I'm pretty proud of myself. That's yeah. So I'll probably so yeah, and the cool thing is, I read online on the YouTube, on the Facebook, on the page order, I can solder directly to the pads, so the alligator clips are connected to here. So basically, the clips from the power going from here is connected to the board on the side and not to the actual blue thing in the center. Um, which is kind of cool. That way, I don't need to take it off if I don't want to. But I might do that anyways, or I might not. I might put a voltage meter on the other side of it just to kind of see how much voltage is getting pushed out of it. Just kind of see what the ratings are and stuff like that. So, but yeah, I think we'll be good, and I might want to. I don't know. I like the charging pads on I like the charging pads on the side there. It's good. I like that, so I might stick with that. But I might read more about it and find that's not the best way to do it. But it should work though. I'm gonna try to plug stuff in and see how it goes, and um, check out the trigger boards and see how the trigger boards work. Maybe I might need to order more, but if as far as I know, I think this one still works pretty good. So just gonna check and see how well it works, and then make sure the pads on this line up, and I'll be happy if they line up pretty good. Yeah, because that's another thing too. Underneath the blue part where it goes to the board, kind of sticks out a little bit. Let's see if we can see it. Sticks, yeah, kind of sticks out a little bit like spikes, and so the board won't lay flat. So that's why I put this on the rubber pad. So I might remove it just for that reason. But then, of course, the potentiometer things does also stick out pretty far too. So I might not remove them after a while. I just maybe got to be more careful. But yeah, that's the latest, man. That is the latest. So we'll see how that goes. It should be all gravy when I'm done with it. Yeah.